Hello, my name is Sean Haler, and I'm a data scientist at Elder Research. In this video, I'm going to walk through a solution to Advent of Code 2024, Day 5. In it, I will be talking about my use of sets, as well as for Part 2, I'm going to implement a bubble sort solution and talk through that. The input for today consists of two main parts. We have a set of rules, as well as a set of lists. The goal is to identify which of the lists are sorted. And a list is sorted, you can tell that by looking at each pair within the list, identifying the rule that associates that pair up above, and in short, if the numbers on the left are the same and the numbers on the right are the same, then the pair within the list is properly sorted. So 75 is on the left down below, it's on the left up above, and so these two numbers, this pair, 7529, is properly sorted. Moving on to the next pair within the list, I'm looking at 7513. I find the rule associated with that, and I again see that this pair is also properly sorted. Finally, I look at the pair 2913 and I find the rule above, and I can see that 2913 is also properly ordered. So all pairs within the list are properly ordered, so then the list itself is deemed to be sorted. Taking a look at the second list I have listed there, 6113, I find the rule and I can see that that's properly ordered. 6129, also properly ordered. But when I get to 1329, the rule up above says that 29 should be to the left of 13. It's not in this case, so that pair is not properly ordered. So then the overall list is not properly sorted. The goal for this problem is to identify all the sorted lists, extract the middle elements from each of those lists, and then sum them up, and that will give you the solution. Before I jump into the problem, I want to talk about how I condensed the rules up above into a single dictionary using sets. So I take each rule, and the left value is going to become a key into my dictionary. The value for that key is a set, and I'm going to add all the elements that occur to the right of that key value to the set of values on the right. So in this case, I have a set and I'm going to add 29 to it, and so 29 is in the set associated with 75. For 6113, I'm going to do the same thing. For 7513, I'm just going to take 13 and add it to the already existing set of elements for 75. When I go through all the rules in my list, my rule dict should look something like this. Jumping into the code, I'm using Python 3.9.12. I'm also using the logging module and the itertools module. The first part of my solution up through here just reads in the list. Reads in the input for the function or for the problem. The input for the problem is my test input, looks like this. My set of rules, a little more complicated than what I had on the slide, and my set of lists, also a little more complicated. The actual input looks something like this. I have 1,200 rules, and I don't know, another 100 to 200 lists to sort. Not pretty to look at. Anyway, I'm going to read in that input. I'm going to put the rules into this rule dictionary that I decided would be useful. And this just outputs the list if I'm testing. I'm going to go ahead and run that so you can kind of see what the output looks like. So here's my rule dict. Here are the elements that should occur to the right of 47. Here are the elements that should occur to the right of 97, and so on. And these are my lists that I need to determine whether or not they're sorted. To determine if a list is sorted or not, I created a check order function, and it returns either true or false if the list is properly sorted or not. In order to determine that, I'm using the itertools.combinations method. I'll pass it my list of page numbers, or my page numbers list, and tell it I want all two element subsets from that list. It's going to return these two element subsets much like how I went through it on the previous slide. So in this case, each xy that it returns, x is going to be to the left of y in this pages. I then check to see if y is in the set of values associated with x, which means y should occur to the right. If it does, that means this will return true, which means that pair is properly ordered. If y is not in that set, this will return false. I'm then using list comprehension to grab all of those true or false values. I'll pass that to the all function. If they're all true, all will return true, and so will my check order function. If one of those values is false, all will return false, and so will my check order function. Getting down into the crux of the problem, I'm going to loop through all my lists. I want to assert that the length of each list is actually odd so that there is a middle element to be pulled from the middle of the list. That's what this assert statement does. I then check the order of the list U. If it passes through that check order, I'm going to extract the middle element using this formula here. Note that I'm using integer division to make sure that this formula actually returns an integer so it can properly index the list U. Once I extract that middle element, I'll add it to my solution, part 1, and then output that solution. For the test input, I got 143. Let me go ahead and run it on my actual input. And I get a value of 4662. For part 2, I'm going to assume that the rule dict is already created. And the goal with part 2 is to sort the unsorted lists from my input, and then again extract the middle elements and sum them up, but just from the newly sorted list this time. In order to sort a list of values, but not according to the values that they actually represent, that can be a bit tricky. So I decided to implement a bubble sort to solve this problem. A bubble sort is a well-known sorting algorithm. It's fairly simple to explain, and that's why I chose it. It's not the most efficient sorting algorithm, so if you're looking to implement a sorting algorithm in production, I recommend a merge sort or a heap sort or a quick sort, something like that. But bubble sort worked for this problem, and so that's the one I decided to go with. In order to implement a bubble sort, I need 2 markers. I'm going to have what I'll call a final marker, which is in blue, and a new final marker, which is in red. Now, bubble sort works through a set of iterations, and in each iteration, I'm going to pass a bubble from the front of the list down to the end of the list, or from the beginning up to the new final, actually. Each bubble is going to consider 2 values, and it's going to sort those values according to whatever rules I decide to give it. So for this first iteration, the first bubble starts at the beginning of the list. I consider 4713. 13 is in the set of values associated to 47, which means it should appear on the right of 47, which it does in this case. So I'm going to leave it alone, and I'm going to let my bubble move on to the second set of values to consider. Now here, 13 is in the list of values associated to 75, which means 13 should appear on the right of 75. So the algorithm says I should swap these 2 values. I'm going to swap them, but I'm going to move my new final marker to point to the end of the bubble. Moving my bubble to the next set of values to consider, I get 1329. Again, the rules up above say that I should swap those values and then update my new final marker. Finally, 1361, also need to swap that, and I'll move my new final marker to the end. Now, my bubble can't consider any more values within the list, so at this point, this portion of the iteration is done. And now I want to move my blue marker to wherever my red marker is, and then return my red marker to the beginning of the list. The value pointed to by the blue marker and every value to its right is now properly sorted. They are in the correct position at the end of the list. So I don't really ever need to consider that 13 again as far as the algorithm is concerned. I'm going to start again with my bubble at the beginning of the list, 4775. 47 is in the set of values associated with 75. And so that means it should appear on the right, so I need to swap those values. I then consider 4729. Those are properly ordered, so I'm going to leave them alone. 2961, I do need to swap these two values, so I'll swap them and update my new final marker. Like I said previously, I don't need to consider that 13 anymore, so this was the last bubble I needed to consider. So I'm going to move the blue marker to where the red marker was and return the red marker to the front of the list, and then pass through with my next bubble. 7547, these are properly ordered. 4761, these are properly ordered. I've now reached the end of my list with that bubble. I'm going to move the blue marker to where the red marker was and return the red marker to the front of the list. At this point, the list is sorted because the blue marker has reached the beginning of the list. Each iteration, the blue marker will move to the left at least a little bit, and sometimes in giant steps, sometimes in little steps, but it will get there eventually. And once you get to this point, you can end the algorithm and return the list as a sorted list. Just jumping back into the code. The code is very similar up until I get to this bubble sorts function that I created. This while loop essentially means while you haven't finished yet, while that blue marker has not reached the front of the list, keep going, set the red marker to be at the beginning of the list, and then move your bubble from the front of the list out to wherever your new final marker is. At each step, the bubble considers the two values I and I minus 1, or indexed by the values I and I minus 1. If those are not properly ordered, then swap them and update your new final marker or your red marker to point to the end of the bubble. Once the bubble reaches the end of the list, this for loop should break. And at that point, I can move the blue marker to where the red marker was, or the final marker to where the new final marker is. Then I will jump back up to the beginning of the while loop, as long as I haven't finished yet, and reset the new final marker to point to the beginning of the list. And it will go through this for loop as many times as it needs to. Once it breaks out of this while loop, I can go ahead and return the pages that it will be the sorted list. The rest of the program is very similar to part 1, except that I'm checking to see if this is not ordered. If it's not ordered, I'm going to sort it and then again extract the middle element of that list and add it to my solution for part 2. On my test input, you can see that I got 123, which the website says I ought to. And running it on my actual input, I get a value of 5,900. Well, that should do it. Thanks so much for listening. As I said before, my name is Sean Haler, and I am a data scientist at Elder Research. At Elder Research, we love Advent of Code because we like solving problems like we find on Advent of Code. And that's one of the reasons we work at Elder Research, is because we get to solve problems like this on almost a daily basis. If you are interested in joining us and helping us solve problems like this for our customers, please check out the links in the description, or you can go to our website at elderresearch.com. Thanks again for listening. I hope you found it enlightening.